April 1942, Smith's Dock Company, Middlesbrough, a civilian shipyard that had never built a warship, launched HMS Rother into the River Tees. 24 months earlier, this yard had no warship construction experience. 24 months earlier, the River-class frigate design did not exist. The Royal Navy had recognized that corvettes were too small and too slow for effective convoy escort in mid-Atlantic. Destroyers were too expensive and took too long to build. The Admiralty needed something between corvettes and destroyers, something fast enough to catch U-boats on the surface, something with enough range to cross the Atlantic, something simple enough that civilian shipyards could build without naval architecture experience, something that could be designed, built, and commissioned in 24 months. The River-class was the answer. 138 were built for the Royal Navy. 70 were built for the U.S. Navy. 10 were built for Commonwealth navies. The design influenced over 300 additional frigates worldwide after the war. British naval architects had created the optimal escort vessel and shared it with the world. The problem was straightforward but desperate. The Battle of the Atlantic was being lost. U-boats were sinking merchant tonnage faster than shipyards could replace it. In 1940, U-boats sank over 1,000 ships totaling 4 million tons. Convoy escorts were inadequate. Flower-class corvettes displaced 925 tons, could make 16 knots maximum, and lacked the speed to pursue surfaced U-boats or the range to escort convoys across the Atlantic. They were designed for coastal convoy work, not ocean operations. Destroyers were effective but scarce. Building a fleet destroyer required 18 months minimum and consumed resources needed for capital ship construction. The Royal Navy had insufficient destroyers for fleet operations and convoy escort simultaneously. The BZ escort shortage was quantifiable. In early 1941, the Admiralty calculated that maintaining continuous convoy coverage on North Atlantic routes required minimum 200 ocean-going escorts. Available forces totaled 90 destroyers and 40 corvettes capable of Atlantic operations. The gap was 70 escorts minimum. U-boat numbers were increasing monthly. Donitz deployed 20 operational U-boats in September 1939. By September 1940, operational U-boat strength reached 50 boats. By September 1941, operational strength exceeded 100 boats. The mathematics were brutal. Without massive escort construction, the convoy system would collapse. Corvettes could not fill the gap. The Flower class was being built rapidly, 145 vessels by end of 1941, but operational experience proved them inadequate for mid-Atlantic work. Their maximum speed of 16 knots was insufficient to pursue U-boats that could make 17 knots on the surface. Their range of 3,500 miles at 12 knots was marginal for Atlantic crossings. Their seakeeping in Atlantic storms was poor, causing crew exhaustion and reducing combat effectiveness. Their armament was minimal, 1 4-inch gun and depth charges only. They could not engage surfaced U-boats effectively. The Admiralty needed a larger, faster, more capable escort that could be built as quickly as corvettes. The design requirements were specified precisely through consultation with operational commanders. Captain Donald McIntyre, commanding the escort group based at Liverpool, provided detailed recommendations based on 18 months of convoy escort experience. Commander Peter Gretton, another experienced escort commander, emphasized the need for speed to pursue surfaced U-boats that use night surface attacks to avoid ASDIC detection. The Western Approaches Command compiled operational data showing that successful U-boat pursuits required minimum 20-knot escort speed. Slower escorts allowed U-boats to escape on the surface. The displacement requirement was calculated from range and seakeeping needs. Analysis showed that maintaining station in force 7 gales required minimum 1,200 tons displacement. Smaller vessels lost speed and suffered crew exhaustion in heavy weather. The fuel capacity for 5,000-mile range required minimum 250 tons of fuel oil. The armament and ammunition stowage required additional displacement. The sensor equipment and crew accommodations added further weight. The calculations produced minimum 1,200 tons displacement, with optimal displacement near 1,400 tons. The new escort must displace between 1,200 and 1,500 tons, providing sufficient size for ocean operations. Speed must reach 20 knots minimum to pursue surfaced U-boats and Maintain convoy position in heavy weather. Range must exceed 5,000 miles to escort convoys across Atlantic without refueling. Armament must include dual-purpose guns for surface and air defense, forward-throwing anti-submarine weapons, and comprehensive depth charge racks. Propulsion must use reciprocating engines rather than turbines because civilian shipyards had reciprocating engine experience but not turbine experience. Turbine production was limited and reserved for destroyers and cruisers. Reciprocating engines were proven technology available from commercial marine engineering firms. Smith's Dock Engineering Company could produce complete engine sets without disrupting naval turbine production. Construction must use commercial shipbuilding techniques to enable civilian yard participation. This requirement was critical. Naval shipyards were building destroyers, cruisers, and capital ships. They could not absorb additional escort production without delaying fleet. Construction. Civilian yards had capacity but lacked warship experience. The design must use construction methods familiar to merchant shipbuilders. Riveted construction rather than welded construction because many yards lacked welding equipment. Commercial hull framing patterns rather than naval framing. Standard commercial plate thicknesses rather than specialized naval armor. The design must be standardized completely with no variations permitted during initial production to prevent delays. Standardization enabled production across multiple yards without coordination overhead. The design process began in mid-1940. The Admiralty's Department of Naval Construction assigned the project to William Reed, a naval architect with commercial shipbuilding experience. Reed analyzed Corvette operational reports, destroyer escort tactics, and U-boat capability assessments. He consulted with escort commanders on required capabilities. The design that emerged incorporated lessons from 18 months of convoy operations. The whole form was based on commercial whale catcher designs proven in North Atlantic conditions. The machinery layout was derived from merchant ship practice. The armament and sensor fit was pure naval requirement. The combination was a vessel that civilian yards could build using familiar techniques but configured for effective anti-submarine warfare. The specifications were finalized in November 1940. Displacement: 1,370 tons standard, 1,830 tons full load. Length: 301 feet 6 inches overall. Beam: 36 feet 8 inches. Draft: 12 feet 9 inches. Propulsion: 2 triple expansion reciprocating steam engines driving twin screws. Boilers: 2 Admiralty 3 drum boilers. Horsepower: 5,500 indicated horsepower. Speed: 20 knots maximum, 16 knots economical cruise. Range: 6,400 miles at 12 knots. Complement: 140 officers and ratings. The armament reflected anti-submarine warfare priorities. Main armament: 2 4-inch Mark 19 guns on single mountings, 1 forward, 1 aft. These guns could engage surface targets and provide limited anti-aircraft capability. Secondary armament: 10-20 mm Ehrlichon cannon in single mountings distributed along the superstructure for close-range anti-aircraft defense. Anti-submarine armament: 1 Hedgehog forward-throwing weapon mounted forward of the bridge, firing 24 contact-fused projectiles in a pattern ahead of the ship. Depth charge armament: 2 depth charge rails aft and 4 depth charge throwers amidships, carrying total of 150 depth charges. The weapons fit emphasized volume of fire against submerged U-boats rather than gun caliber. The sensor and detection equipment was comprehensive. Type 1, 2, 3A. ASDIC sonar. Set mounted in a dome below the forward hull, provided submarine. Detection to 2,500 yards in good conditions. Type 271 radar provided surface search capability to detect surfaced U-boats at ranges exceeding 5 miles. HFDF high-frequency direction. Finding equipment allowed detection of U-boat radio transmissions. The sensor integration provided multiple detection methods covering different tactical situations. The twin-screw configuration was deliberate. Single-screw vessels could be disabled by single propeller damage. Twin screws provided redundancy. If one engine or shaft was damaged, the vessel could return to port on the remaining propulsion. This redundancy proved invaluable in combat. Multiple River-class frigates survived U-boat attacks that damaged one propeller shaft, but returned to base on the other. The twin-screw arrangement also improved maneuverability during anti-submarine attacks, allowing tighter turns when prosecuting sonar contacts. Production planning was as important as design. The Admiralty identified 33 British shipyards capable of building River-class vessels. Most were civilian yards with no warship experience. Smith's Dock Company at Middlesbrough had built trawlers and small merchant vessels. Their largest previous construction was a 600-ton trawler. The River-class, at 1,370 tons, was more than double anything they had built. Smith's Dock at South Bank had built cargo ships up to 4,000 tons, but never warships with armament installations or complex sensor equipment. Fleming and Ferguson at Paisley had built merchant vessels and paddle steamers, but no naval vessels. Hall Russell at Aberdeen had built trawlers and small coasters for the fishing industry. Barclay Curley at Glasgow had merchant ship experience, but no warship orders since the previous war. These yards received complete standardized plans with every frame, plate, and fitting specified exactly. The plans were comprehensive beyond typical merchant ship. Documentation, hull plate drawings specified exact dimensions with tolerances measured in 1/16 of an inch. Frame spacing was standardized at 24 inches throughout the class, regardless of yard. Bulkhead locations were specified to precise measurements. Machinery foundations used standard bolt patterns that matched engine sets produced at Smith's Dock Engineering Company. Piping runs were drawn, showing every valve, fitting, and support, with part numbers cross-referenced to procurement specifications. Electrical wiring diagrams showed every circuit with standardized color coding. The detail level eliminated guesswork. No improvisation was permitted. Every yard built to identical plans without any modifications or improvements. This discipline was enforced through Admiralty inspection. Inspectors rejected any construction that varied from approved drawings, even if the variation appeared to improve efficiency. One yard attempted to relocate a ventilation trunk by 8 inches to simplify pipe routing. The inspector rejected the modification and required reconstruction matching the plans exactly. The rigidity seemed wasteful to civilian yard managers accustomed to field engineering, but the standardization enabled the production system to function at scale. Parts manufactured for one vessel could be installed in any other vessel. Prefabricated assemblies could be distributed between yards to balance production loads when one yard fell behind schedule. This standardization enabled parallel production without coordination delays. One yard's difficulties did not affect other yards. If Smith's Dock Company encountered steel delivery delays, other yards continued building without impact. Parts were interchangeable between vessels, regardless of which yard performed construction. A depth charge thrower manufactured at one location could be installed on any River-class vessel. Crew training was standardized because every ship was identical in layout and equipment. An officer trained on HMS Rother could transfer to HMS Teviot built at a different yard and find every control, valve, and indicator in the identical location. The standardization created operational efficiency that multiplied the value of mass production. The construction timeline was aggressive. First steel was cut in January 1941 at Smith's Dock Company for HMS Rother. The keel was laid in March 1941. The hull was launched in April 1942. Fitting out was completed in August 1942. Trials were conducted in September 1942. Commissioning occurred in November 1942. Total time from first steel cut to commissioning, 22 months. This matched Corvette construction times, but produced a vessel 50% larger with significantly more capability. If you're enjoying this analysis of British warship production excellence and how the River-class design influenced global frigate development, a quick subscribe helps support the channel. Production accelerated rapidly. By end of 1942, 18 River-class frigates were in service. By end of 1943, 65 were operational. By end of 1944, 112 were operational. Final production totaled 138 vessels for the Royal Navy. Peak production rate reached 12 vessels commissioned per quarter in mid-1944. No other warship class of comparable size was produced faster. The production rate exceeded destroyer construction by a factor of 3. The River class solved the escort shortage through mass production of adequate capability. The Canadian production was parallel but modified. The Royal Canadian Navy required escorts for Atlantic convoy operations, but Canadian shipyards had different equipment and construction practices. The River class design was modified to use Canadian engines, boilers, and equipment. The revised River class displaced 1,445 tons standard due to different equipment weights. Canadian yards built 60 revised River class vessels between 1942 and 1944. These vessels served primarily in Western Atlantic convoy routes and coastal operations. The modifications proved that the basic design could accommodate equipment variations while maintaining combat effectiveness. The U.S. Navy adopted the design directly. In 1942, American shipyards began constructing patrol frigates designated PF class based on British River class plans. The specifications were nearly identical. Displacement, 1,430 tons standard. Speed, 20 knots. Armament, 3 3-inch guns, Hedgehog, depth charges. The differences were minor adaptations for American equipment. 21 American yards built 75 PF-class vessels for the U.S. Navy and 21 for the Royal Navy under reverse Lend-Lease. The Royal Navy vessels were commissioned as Colony-class frigates. The production demonstrated that the design worked in American construction practice as effectively as British practice. American yards also produced the Tacoma-class patrol frigate, a slightly modified River-class design with improved habitability and different armament fit. 96 Tacoma-class vessels were built between 1943 and 1945. The design lineage from British River-class was explicit. American naval architects acknowledged that the Tacoma-class was an evolutionary development of the proven British design rather than an independent creation. The total American production of River-class derived frigates exceeded 170 vessels, more than the Royal Navy's own production. Combat performance validated the design immediately. HMS Rother participated in convoy escort operations from November 1942 through the end of the war. She escorted 73 convoys across the Atlantic without losing a single merchant vessel to U-boat attack while under her direct protection. Her anti-submarine warfare record included 3 confirmed U-boat kills and participation in 4 additional kills shared with other escorts. The first kill came in March 1943 when Rother detected U-633 on Aztec at range 1,800 yards. Rother closed to attack, fired Hedgehog, and achieved contact detonations that destroyed the U-boat with all hands. The Hedgehog proved its value. Traditional depth charge attacks would have required Rother to pass over the contact, losing Aztec detection during the attack run. Hedgehog allowed Rother to maintain sonar contact throughout the attack. The pattern repeated across the class. HMS Waveney sank U-415 in July 1943 using coordinated Hedgehog and depth charge attacks. HMS Naney participated in the destruction of U-238 in January 1944 as part of a support group operation. HMS Teviot damaged U-264 so severely in March 1944 that the U-boat was forced to surface and scuttle. River-class frigates participated in the destruction of dozens of U-boats and escorted thousands of convoy crossings. The operational tempo was relentless. Ships spent 15 to 20 days at sea per convoy cycle, returned to port for 4 to 5 days to refuel and resupply, then departed for the next convoy. Crews endured North Atlantic winter conditions with waves exceeding 40 feet and temperatures below freezing. The River-class seakeeping proved adequate for these conditions where corvettes struggled. The operational effectiveness derived from balanced capability. The 20-knot speed allowed River-class frigates to pursue surfaced U-boats that could outrun corvettes. When a U-boat was detected on the surface at night, River-class frigates could close the range before the U-boat could submerge and escape. The 6,400-mile range allowed continuous Atlantic escort without refueling stops. Convoys could maintain escort coverage throughout the crossing, The Hedgehog forward-throwing weapon allowed attacks on submarine contacts without losing sonar contact. Conventional depth charge attacks required the escort to pass over the submarine, losing sonar contact during the attack run. Hedgehog fired ahead while maintaining sonar contact, improving kill probability significantly. The twin-screw configuration proved its value in damage survival. HMS Lagan was torpedoed by U-667 in March 1944. The torpedo struck near the stern, destroying the starboard propeller and shaft. Lagan continued operating on her port engine, returned to Londonderry under her own power, and was back in service after repairs within 6 weeks. A single screw vessel would have required towing and months of repair. The redundancy saved the vessel and returned her to operational status quickly. The production run included continuous improvements. Early River-class vessels mounted Type 1, 2, 3 ASDIC. Later vessels received Type 144 ASDIC with improved range and accuracy. Early vessels had Type 271 surface search radar. Later vessels received Type 277 radar with better target resolution. Anti-aircraft armament was enhanced continuously. Early vessels mounted 620mm Oerlikons. Later vessels mounted 10 Oerlikons plus 2 twin 40mm Bofors guns for improved anti-aircraft defense. These modifications were incorporated into production without disrupting the build schedule. Ships under construction received the latest equipment. Ships in service were retrofitted during scheduled maintenance periods. The design influenced post-war frigate development worldwide. The Royal Navy's Loch-class and Bay-class frigates of 1944 were direct River-class descendants with modified armament and improved anti-aircraft capability. The basic hull form, machinery arrangement, and twin-screw configuration remained unchanged. The Bay-class displaced 1,600 tons, only 16% larger than River-class, but incorporated wartime lessons in a refined design. 26 Loch-class and 26 Bay-class frigates were built, continuing the River-class production lineage through war's end. International adoption was extensive. The Royal Australian Navy operated River-class vessels during the war and retained them in service post-war. The Royal New Zealand Navy operated River-class vessels and used the design as the basis for their post-war Loch-class purchases. The South African Navy operated River-class vessels and continued operating them into the 1960s. The Indian Navy received River-class vessels and operated them as their primary anti-submarine warfare platforms until the 1970s. The design's longevity demonstrated its fundamental soundness. The comparison against German rapid production programs is instructive. Germany attempted rapid U-boat production with the Type 21 U-boat program in 1943. The Type 21 was technologically advanced with high underwater speed and snorkel capability. Production was planned using prefabricated sections built by multiple yards and assembled at final yards. The program failed. Coordination between yards was inadequate. Quality control was poor. Sections did not fit properly during assembly. Production time per U-boat increased rather than decreased. By war's end, 118 Type 21 U-boats were completed, but only 2 became operational. The program consumed resources without producing combat capability. The British River-class program succeeded where the German Type 21 program failed because of different approaches. The River-class used proven technology rather than experimental systems. Reciprocating. Engines were reliable and familiar to civilian yards. The design required no innovations. It simply combined existing components in an optimal configuration. The standardization was absolute. Every yard built to identical plans without deviation. No yard attempted improvements or modifications. Parts were interchangeable between vessels built in different yards. Crew training was identical across the fleet. These factors enabled rapid production with consistent quality. The American destroyer escort program learned from British frigate experience. The DE destroyer escort program began in 1941 using diesel-electric or turbo-electric propulsion for fuel economy. Early DE production encountered machinery reliability problems and construction delays. American observers studying British River-class production noted the simplicity of reciprocating steam engines and the rapid build times achieved by civilian yards. Later DE classes incorporated reciprocating steam engines, similar to River-class machinery. Production rates improved immediately. The Buckley-class and Rother-class destroyer escorts used reciprocating engines and were built in quantities exceeding 150 vessels. The British example influenced American production philosophy directly. The strategic impact was quantifiable. In early 1943, before River-class production reached significant numbers, monthly merchant ship losses in the North Atlantic averaged 96 vessels. By late 1943, with River-class and American PF-class escorts entering service in numbers, monthly losses dropped to 37 vessels. By early 1944, monthly losses fell below 15 vessels. The escort shortage was solved. Convoys had sufficient protection. U-boats faced overwhelming anti-submarine warfare capability. The production of adequate escorts in sufficient numbers changed the strategic balance in the Atlantic. The economic comparison against destroyers justified the production priority. A River-class frigate cost approximately £275,000 to build. A fleet destroyer cost approximately £800,000. 3 River-class frigates could be built for the cost of 1 destroyer. Construction time for a River-class was 22 months. Construction time for a destroyer was 30 months. River-class production delivered more escort capability faster and cheaper than destroyer production. The Admiralty allocated resources to maximize escort numbers rather than individual vessel capability. The strategy worked. The operational flexibility was significant. River-class frigates could operate independently on patrol duties, could escort convoys in groups of 4 to 6 vessels, or could operate with fleet destroyers in support group operations. They filled multiple roles effectively. When escort carriers became available for convoy support in 1943, River-class frigates operated as carrier escorts, providing anti-submarine screen while the carrier's aircraft prosecuted distant contacts. The versatility maximized their tactical value. The design philosophy was fundamentally British. Good enough quickly beats perfect slowly. The River-class was not the best possible escort. It was the best escort that could be designed in 6 months and built in 22 months by civilian yards with no warship experience. It was adequate for every mission required of it. It was producible in quantities sufficient to solve the escort shortage. It was reliable enough to operate continuously without excessive maintenance. It was simple enough that hastily trained crews could operate it effectively. These qualities made it more valuable than a theoretically superior design that would have taken longer to develop and build. The post-war legacy confirmed the design's influence. The River-class established the frigate as a permanent warship type. Before the River-class, navies operated destroyers and corvettes with no intermediate type. The gap between 900-ton corvettes and 1,800-ton destroyers left no ocean-going escort optimized for anti-submarine warfare. After the war, every major navy operated frigates as standard anti-submarine escorts. The frigate concept, an ocean-going escort larger than a corvette but smaller and cheaper than a destroyer, became universal. Modern frigates displace 4,000 to 6,000 tons and mount sophisticated weapons and sensors, but they descend directly from the River-class design philosophy. The role is identical. The mission is unchanged. Hunt and kill submarines while protecting merchant shipping and naval task forces. The weapons have evolved from Hedgehog to guided torpedoes and missiles. The sensors have evolved from ASDIC to towed array sonar and hull-mounted active-passive systems. The fundamental mission remains exactly what the River-class was designed to accomplish in 1940. The technical lineage is traceable. Modern frigate design features twin screws for redundancy, sonar mounted forward for optimal performance, economical propulsion for long-range operations, and balanced armament for multiple threats. These characteristics appeared first in the River-class design. Subsequent frigate classes refined the details but retained the fundamental configuration. The River-class established the template that remains valid 80 years later. The production achievement was never exceeded in relative terms. 138 River-class vessels built by the Royal Navy in 36 months represented the fastest production of ocean-going warships in British naval history. The American production of River-class derivatives totaled 170 vessels. Canadian production added 60 vessels. Commonwealth production added 10 vessels. The grand total exceeded 390 vessels of River-class lineage built during the Second World War. No other warship design was produced in such numbers in such a short time, using such distributed production capacity. The influence extended beyond Anglo-American navies. Soviet naval forces received River-class frigates under Lend-Lease and copied the design for post-war production. The Kola-class frigates built in Soviet yards after the war were modified. River-class designs with Soviet weapons and equipment fitted to the proven British hull form and machinery arrangement. French naval forces studied River-class characteristics when designing post-war escorts, including the Le Corse-class frigates. The design's influence was global because its fundamental soundness was recognized universally. Naval architects worldwide acknowledged that the River-class had solved the escort design problem optimally within the constraints of wartime production. April 1942, Smith's Dock Company launched HMS Rother, the first of a class that would solve the battle of the Atlantic escort shortage, establish the frigate as a permanent warship type, and prove that British naval architecture could deliver optimal designs faster than enemies could counter them. The River-class was not revolutionary. It was evolutionary excellence. It combined proven technology, practical design philosophy, and absolute standardization to produce a vessel that civilian yards could build, naval crews could operate, and maritime strategy required. 138 vessels served the Royal Navy. Hundreds more served Allied navies. Thousands of convoy crossings were protected. Dozens of U-boats were sunk. The escort shortage was solved. The Atlantic was secured. British naval architects had designed the solution, shared it freely with allies, and established the standard for escort vessels that endures to the present day. Good enough quickly had beaten perfect slowly. The River-class proved that overwhelming production of adequate capability defeats limited production of superior capability. The lesson was strategic, the design was timeless, the influence was global.